work here, pal. Buddy the Elf, what's your favorite color? Put that down.
Hello? Hello?
Hello? Hello? My favorite color is green! Okay, so in the last video we were talking about functions, which is where Excel created a math problem for you. We used the functions AutoSum, Max, Min, and Average. In today's video, we're going to be talking about formulas, which is the direct inverse, and you have to actually create the math problem for Excel to do. And now we write our formulas using different cell references. So if you haven't already, make sure you pull up the formula start Excel file, which looks like this. Watch me magically transform into another person to help you along with this tutorial. Wrong person. Dog. Let's give this another try.
Remember using formulas to calculate math problems in school? Like 2 plus 2 equals 4, or 2 pizzas times $10 equals $20? You can use these same formulas to work with numerical data in your spreadsheets, just like you would use a calculator. Excel uses standard operators for math equations, like a plus sign for addition, a minus sign for subtraction, an asterisk for multiplication, a forward slash for division, and a caret for exponents. You're probably used to seeing equations like 5 plus 5 equals, but in Excel, the equal sign comes first. That's because the cell itself contains, or is equal to, the formula and its value.
Yeah, me again. So we could use Excel like a calculator and use it for standard math operations. So for example, we did equals 2 plus 2 and got 4. Or we could try that pizza example, and do equals 10 times 2 and get 20. But that's why we have a calculator. Most of the time when we use Excel, we're going to be using numbers already inserted into our worksheet that we want to do some math for. So here's an example of that.
Let's start off with a simple addition formula. We're going to calculate the total budget for June and July. However, instead of entering these numbers, in other words, 1,200 plus 1,500, we're going to use cell references. Here's how it works. First, select the cell where you want the total to appear. Then type an equal sign, which is how you always start a formula. Next, type the addresses of the cells you want to add. In this example, D10 plus D11. Notice how the cells you've entered are actually highlighted in your worksheet, so you can easily confirm the contents of your formula. When you're ready, press Enter on your keyboard, and Excel will display the answer. Now, you may be wondering why we used cell references instead of numbers. It's because they give you the ability to change your original values without having to retype your formula. Excel automatically recalculates the answer, so it's always up to date. For that reason, you should try to use cell references whenever you can. To edit your formula, all you have to do is double-click the cell. If you make a mistake or change your mind, you can press Escape on your keyboard, and it'll go back to the way it was. Let's try another example, this time with multiplication. I want to calculate the total price for plastic silverware, so I'll need to multiply B4 by C4. Once again, start by typing an equal sign. But instead of entering the addresses manually, we're going to use something called the point and click method. Just click the cell you want, and the address instantly appears in your formula. Most people find this much easier than typing out the cell addresses by hand. When you're done, press Enter, and the answer appears. Finally, I want to show you a quick way to add a formula to several cells at once, specifically these 3 cells. Instead of retyping the formula above, we're just going to select the first cell, then locate the fill handle in the bottom right corner. Click and drag the handle down, and when you let go, the formula appears automatically in all 3 cells. Now we can see the total cost for each item. This is a great shortcut for duplicating formulas if you plan to use the same one more than once.
But wait! There's more! Hang on to your seat, baby! Cause this one's a screamer! I'll be back.
Sometimes when you're entering a formula or a function, you're going to see the number sign or the hashtags. This simply means that the cell is not wide enough to show all the information. So all you need to do is widen your cell either by clicking and dragging, or remember you can double click to auto fit. Now go ahead and open the challenge sheet at the bottom of your workbook. In the challenge sheet, you should create a formula in cell D4 that will multiply the quantity in B4 by the price per unit in cell C4. Then, use the fill handler to copy the formula in D4 down to D7. Change the price per unit for the fried plantains in cell C6 to $2.25. Then, edit the formula for the total in cell D8 so that it is also adding D7. Your workbook should now look like this. If it doesn't, go back, recheck your formulas, or ask Goose for help.
You may already have some experience creating simple formulas that have only one type of operation, but sometimes you have to create more complex formulas that do have more than one operator, for example, addition and multiplication. To do this correctly, you'll need to understand how Excel is calculating the answer. When solving formulas, Excel uses a set of rules called the order of operations, which you might remember from math class. The order of operations determines the order in which the formula will be calculated, so you know exactly how to write it out. The first thing that's calculated are any equations in parentheses. Then, if you have any exponents, you'll calculate those. Next is multiplication and division, and finally, addition and subtraction. Excel knows to use the order of operations whenever it calculates a complex formula. It's important that you remember it so you can create formulas that'll give you the correct answer. To remember the order, you can just use the acronym PEMDAS. Or to make it even easier, remember the phrase, "Please excuse my dear Aunt Sally." Let's take a closer look at some examples.
Make sure you open up the catering invoice sheet located at the bottom of your workbook.
In this example, I'd like to add these three values and find out how much the sales tax will be. I'll start by typing the equal sign, which is how you always start a formula. Then I'll calculate D3 plus D4 plus D5. Next, I'll multiply by 0.075, which is the tax rate at 7.5%. Now, this may look like it's going to give us the correct answer, but it's not. That's because we didn't follow the order of operations. Remember, multiplication comes before addition. So Excel is going to multiply D5 by 0.075 first, then it'll add D3 and D4, which isn't what we want. We want these three values to be added first. So to do that, we just need to put them in parentheses. Parentheses are often the best way of controlling which parts of the formula are calculated first. And when this formula is calculated, we can see that the answer is $20.56. Writing complex formulas really isn't that difficult once you know how they work. Just remember to use the order of operations and you'll get the correct answer every time.
2,000 years later, 6.5 hours later, a few inches later, day 2, day 3, day 4, a few moments later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Tomorrow for sure. Eventually, 12 o'clock midnight. Several bad puns later. 1 hour later. 2 hours later. 3 hours later.
Can you move it along? I'm all out of time cards.
Now that you can write formulas using different cell references, we're going to look at the different types of cell references. In this portion of the video, we're going to start on the Menu Order No Tax tab, and then we will flip to the Menu Order tab, and finally, you'll complete Challenge 2 at the very end. So go ahead and start on Menu Order No Tax.
There are two main types of cell references in Excel, relative and absolute.
And actually, I'm going to add 2 more to give us a total of 4. We'll also be using Mixed Varying Column and Mixed Varying Row.
Both behave differently when copied to other cells, either as part of a formula or a function. Relative references are the default, and probably the type you're going to use for most of your formulas. In this example, I need to know the total cost of each menu item on the invoice. To do this, I'll need to multiply the values in these 2 cells. I'll just enter my formula here. Start by typing the equal sign, and then the formula will be B4 times C4. When you're done, press Enter on your keyboard. Now if I use the fill handle to copy this formula to all of these cells, We can double-click each copy and see that the cell references have changed automatically. So we have B5, B6, B7, and so on. That's because these are relative references. In other words, when Excel looks at our original formula, what it actually sees is the location of the cells relative to the location of the formula. That means in this case, it's looking at the two cells to the left of our current location, and those just happen to be B4 and C4. Each copy is also looking at the two cells to the left of the formula. This technique is useful because it means we can copy the formula as we did here, and the cell references will sort of move along with it. The references don't even have to be in the same row. They can be anywhere in the sheet. There may be times when you don't want the cell references to change. Take this version of the invoice. I've added a column where we can list the sales tax for each item. We should be able to enter our formula here, then copy it to the rest of the list. To get started, I'm going to enter B4 times C4 in parentheses. Then I'm going to multiply by cell E2, which contains our tax rate at 7.5%, which is the same as 0.075. Next, I'll use the fill handle to copy the formula to the rest of these cells. But wait, that doesn't look right at all. It's even affecting the formulas in the rest of the worksheet. The first copy of our formula is correct because it's multiplying by E2, which contains our tax rate. But as we go down the list, we can see that the reference is moving in relation to the cells, which isn't what we want. We want it to stay frozen on E2 for each copy of the formula. And for that, we'll need to use an absolute reference. Absolute references have a $sign placed before the column, row, or both to keep them from changing when you copy the formula to another cell. To keep the column and the row from changing, place a $sign in front of both.
So the $sign acts as a way to lock in or freeze that column or row. Now let's take a look at our mixed cell references.
To keep only the row from changing, place a $sign in front of the row only.
This is called a mixed varying column reference because my column will be able to vary or change, but my row is absolutely locked, frozen in with that $sign.
To keep only the column from changing, place a $sign in front of the column.
This is called a mixed varying row cell reference because the row gets to vary or change when the column is locked in, absolutely frozen.
Most of the time, you'll be using the first type of absolute reference, the one where there's a $sign before the column and the row. Let's go back to our example and add $signs before the column and the row to make E2 an absolute reference.
If you were nervous about typing in the $signs, simply click your mouse in the cell reference and press F4 to change that reference. If you press F4 multiple times, Excel will cycle through the different types of cell references.
Now if we copy the formula to the rest of this list, the errors go away, and we're left with the correct sales tax for each item. The relative reference is different in each cell, but the E2 reference, our absolute reference, stays the same.
Let's practice bringing everything together by completing the Challenge 2 worksheet at the bottom and filling in the sales tax column. We're going to first write a formula, and in that formula, we're going to use our absolute and relative cell references. So remember, click in the cell we want our answer in, and always start your formula with equals. Then determine what you're trying to do for the math. In this case, we want to multiply our unit price by our quantity, and it's important to use our order of operations, ensuring that this happens first. Then I'm going to multiply that by my sales tax rate of 6%. This 6% needs to stay frozen and locked in. It can't change. So I have to make this an absolute cell reference. I can press F4 to cycle through the types of cell references. Make sure that you have a $sign before the row and the column since we're locking both in. Press Enter to secure your formula. Then use the fill handler in the bottom right-hand corner to copy your formula throughout the worksheet. If you got this done, go ahead, do a final file save to your computer apps folder, and then submit this to Schoology. Woohoo!